Hello and welcome to what is a very warm lab where I'm going to be showing you a little bit about the basics of particle accelerators. So we've already had a quick look at the electrostatics equations, but now let's just see everything in action so you get a better visual view of what's happening. You can see I've got my ramp here. We've got a force going downwards, so that's just here. That's going to be our electric field, so we're accelerating our ions along. We have a force which is going to be coming in from the right, so that's over here. You can see we've got a wind machine, which I'm going to turn on in a second, and then we've got our particles as well. So I've got a little ping pong ball, really light. I've got a sponge ball, stress ball thing, medium mass, and then I've got a cricket ball, quite heavy. So I can show you what's going to happen, and hopefully you already know, but we'll start at the same point on the ramp, on my little start point, and you'll see that they should all hopefully just sort of roll away perfectly normally, no issues. Okay, that's the ping pong ball. Let the squash ball go. Okay, well it's gone off to the right, but no real change in direction. And then the cricket ball, you can see because of the actual roughness of the ball there and the texture on it, it hasn't gone in a straight line either. So let me go and collect those. Okay, so now I'm going to turn the wind machine on. Hopefully you can hear me over that. So I've just started it quite low, and this is going to be the equivalent force from your V cross B that's produced. Okay, so we'll do it again. Start with the smallest, lightest ball, and you can see what's going to happen. And you can see an immediate deflection there. Squash ball. And you can see a very small deflection. And then the cricket ball, maybe a little bit of deflection, maybe it's just the table not being even, but you can see that the lighter the ball, the more impact the force is going to have. So now if we make the magnetic field stronger, and of course by magnetic field what I mean is the V cross B. Instant deflection. For the squash ball, again you can see there's quite a strong deflection again. And the cricket ball didn't do much at all. Okay, so I've just knocked the wind machine down for a few seconds. We're going to put it back up to the high end, and we're going to do the experiment again. Obviously you should know what's going to happen next. There's going to be increased deflection for all masses. And there's probably no way you're going to hear me on this. So we've seen what happens with a changing magnetic field. Now if we have a higher or lower electric field pushing those charged particles through the spectrometer, that deflection is going to be different as well. And that's what I'm going to demonstrate next. So I'm going to put the wind machine on about medium, and you're going to see me testing this at a few different heights of ramp, which is going to correlate to a stronger electric field. And you can see how that affects the deflection as well.